This is our last example. It's 2.2, day 2, part 3. Like I said in the last video, if you wrote the last example down, then this one you might want to just watch and listen. You can help me out. So now we have the function f of x equals 3x to the fourth minus 4x cubed. So let's talk about the degree. What is the degree in this problem? What's the degree? 4. Is it even or odd? Even. Is the leading coefficient even or positive or negative? It's a positive 3, so it's greater than 0. So what does that mean for my end behavior, my leading coefficient test? Rise left, rise right. Think about those quadratics. It's rising on the left and it's rising on the right. All right. Now, that degree is 4, so what is going to be the shape of a quartic function? Is it a snake? No. It's going to be the W or the M. Now look at my end behavior. Now can we tell which one it's going to be? It's rising on the left and it's rising on the right. So it's going to be the W. So I'll erase this. So I know my graph has to look something like that. So now the next step is to go out and find the zeros of the function, which will be the x-intercepts. So I'm going to set this function equal to 0 and solve for x. Factor out the GCF. And that's what I'm left with. I took out an x cubed. Now I set the factors equal to 0, and I solve for x. Well, if I cube root a 0, I'm still going to get a 0. So now I have a repeated 0 again. Over here, I add 4, and then divide by 3. Now let's talk about the multiplicity. Repeated 0. Is the power even or odd? Is this power even or odd? Odd. So let's go back to this part of our notes that I had you write down. If the k is odd, what happens? It crosses the x-axis. It goes through the x-axis at that point. All right, so let's identify the x-intercepts. What are the x-intercepts?
0,
0, 0, and then 4/3. And if you want to change that to a fraction to a decimal, that's 1.3, comma 0. Then identify if it has x, y, or origin symmetry. For those of you who are right now, I'll give you a little bit of time to catch up. So now we'll check and see if there's some symmetry. Are you guys okay if I just do this part quickly? Negative x, you substitute it in, negative, what's the original function? Should have this up here. 3x to the 4th. 3x to the 4th minus 4x cubed. So we're testing to see if there's symmetry to help us with some additional points. 3 negative x to the 4th minus 4x cubed. When I simplify that, I'm going to get a positive x to the 4th and a positive 4x cubed. Did I get my original function back? No. If I pull out a negative, I also don't get my original function inside with a negative out in front. So, no symmetry. All right, let's go down to graphing what we know right now. We know the x-intercepts, and I'm going to scale this a little bit bigger. It's tiny. So I'll make this 1, 2, 3, 1, 2, 3. All right. So one of the intercepts was at 0, 0. And then one of the other intercepts was at 4/3, which is 1.3, and then 0. And let's talk about the end behavior next. The end behavior said it's rising on the right and rising on the left. So what's going to happen is this has to go up, because it cannot go back down, or we'd have to have another x-intercept, which we don't. And then on this x-intercept, it also has to go up. It can't go back down. And then something happens in between those intercepts. Now, the shape has to be a W. Does the W always have to look like a W in the alphabet? Maybe it looks like this, and then it goes just a little bit. And that can happen. And we're not going to be too picky about how far down you go, because we don't have a lot of room to show that. So now, let's talk about the multiplicity. That repeated 0 at 0. That was odd. So when I go to this x-intercept, what did it say it can do? It can go through the x-axis. So it's not going to jump back up. It's going to go down some distance. Then it has to have the shape of the W. So I'm just going to save some time. If we look back at this step right here, let's put this here, it goes through x-axis. I just did the evaluation in a chart form for you. So here was one of your x-intercepts. Here's another x-intercept. And then we just plugged in a few more points. So you evaluate the function at -1. That should be positive, and it is, it's 7. Then it kind of drops down. At 1, it's at -1. And then at 1.5 to the right, it goes up. So it should do that. So at -1, it's way up here at 7. At 1, it's down at -1. And then what happens is kind of hard to tell. It just does a little loop. It's very slight, little W. The only way to really tell that is if you kind of keep going inside those values between maybe 0 and 1 and see if you see a little loop. That finishes our lesson for today. Oh, I forgot these. No, it's not. These go fast. I would just write one of these down. So now we're going to the opposite. We're going to give you the zeros, so the x-intercepts, and we want you to write a function. And there's multiple answers that can exist. So those are the x-intercepts, 0, -2, -3. And we want to find a polynomial function. Did we? I don't think so. Yesterday we found the zeros. Now they give us the zeros. We go opposite. We write the equation for it.
There was one problem in this time.
Was there? Oh. All of these work, and I'll explain what this means. The first step is Remember, you always have to think opposite with your zero. So in factored form, it'd be x minus 0, x minus negative 2, x minus negative 3. So there's one possible answer. Most of you probably wouldn't leave it like that with the double negatives. Most of you probably clean it up to this form. Now it's in factored form. That would be an acceptable answer. Or if you want to take the time and multiply the x plus 2 and the x plus 3 by foiling it and cleaning it up, you can have that as an answer. Or you could take the time and multiply again the x through. Look at the degree. The degree is 3. How many zeros do I have? 3 zeros. So any of these answers in your homework would be possible today. Maybe you wanted to write one of those down or two of those down. And then here's the exact same problem, just some different numbers. Don't write this one down. So now they give you the degree is 2. So that means you can only have a quadratic function. There's the zeros, x minus 8, x minus 4. So any of these answers would exist. This is probably the most popular one, but if you want to take the time to FOIL it out, you could do that also. All of those are functions for those zeros. Alright, here's your homework for today. And I did give you some helpful hints on question 89 on the next slide. So if you go to my PDF on the downloads page, I gave you some helpful hints on how to do that word problem again. This weekend I recommend you also go out and start looking at that review worksheet because you do have a quiz next week, Thursday and Friday of your final exam time. And it's non-calculator. No graphing calculator.